In July 2025, an extraordinary cosmic event caught the attention of the scientific community and astronomy enthusiasts around the world. Comet 3I Atlas, the third interstellar comet discovered so far, was officially detected, and since then, it has been the subject of intense observation. Although comets are not new to astronomers, the origin and behavior of Comet 3I Atlas make it a fascinating anomaly that has challenged our understanding of these celestial bodies. With a hyperbolic trajectory, Comet 3I Atlas did not originate from anywhere within the solar system. It is a true cosmic visitor, coming from beyond our galaxy. Comet 3I Atlas was identified by the Atlas telescope, located in Chile on July 1, 2025. However, it had already been approaching the solar system for some time, and by the time it was discovered, scientists had noticed unusual signs that sparked interest regarding its origin and behavior. Comet 3I Atlas is considered an interstellar object because its trajectory is not bound by the sun's gravity, but rather by its motion through the galaxy. This means that, unlike comets from the solar system that follow predictable orbits, Comet 3I Atlas is a visitor from another part of the universe, possibly from a distant star, and is not part of our cosmic family. Throughout September 2025, Comet 3I Atlas revealed itself to be even more surprising. Astronomers from around the world have been observing the interaction of this comet with the Sun and other celestial bodies, and the data collected has raised important questions about the composition of interstellar comets and the dynamics of objects traveling through the vastness of space. During the first week of September, scientists from the Very Large Telescope, VLT, of ESO in Chile began observing unusual activity in the comet. Instead of only releasing typical gases like water and carbon dioxide, Comet 3I Atlas began emitting an unexpected amount of cyanide and nickel. This phenomenon led to an increase in gas emission, causing the comet to display a rather interesting color change. Initially appearing reddish, the comet began to exhibit a greenish hue, suggesting that something inside it was activated as it approached the sun. This type of color change is not common and raises questions about the chemical reactions taking place inside the comet, which in turn may offer clues about the origin and composition of Comet 3I Atlas. The main reason this is relevant to scientists is that, as it approaches the sun, the comet undergoes thermal acceleration, releasing gases and particles that form its coma, a kind of bright halo surrounding the comet's nucleus. However, the amount of cyanide and nickel detected was much higher than expected. Cyanide, in particular, is an extremely toxic gas, and its presence in large quantities suggests that Comet 3I Atlas may contain chemical compounds not found in comets of the solar system. This opens a series of possibilities about the comet's composition and the processes occurring as it heats up due to its proximity to the sun. Another intriguing aspect of the investigation into Comet 3I Atlas is its chemical composition. Using the James Webb Space Telescope, astronomers detected a surprising amount of carbon dioxide in the comet's coma. Surprisingly, the amount of CO2 was 8 times greater than the amount of water found in the comet, a ratio never before observed in solar system comets. Comets from our solar system typically release more water than any other gas, but Comet 3I Atlas is showing a completely different pattern. In addition to CO2, other compounds, such as carbon monoxide, sulfuric acid gas, water, ice, and dust particles, were detected. These compounds indicate that Comet 3I Atlas may have formed in a colder and more distant region from its parent star, possibly far beyond the region where planets formed around its native star. This unusual composition suggests that Comet 3I Atlas may be much older than the comets we know from our solar system. Having traveled for millions of years in intergalactic space, it could be a remnant from a time long before the formation of the solar system, possibly even from the formation of the galaxy itself. This means that Comet 3I Atlas could contain valuable information about the chemical composition of the early universe and the first stages of star and planet formation. But the surprises don't stop there. In September, observations made by scientists from NASA and other space agencies revealed that Comet 3I Atlas displays extreme negative polarization. Polarization is a characteristic that describes how light is reflected from an object's surface, and the polarization of Comet 3I Atlas is different from any other comet or asteroid we have observed. This phenomenon is particularly interesting because it may indicate that the surface of the comet is made of dark, frozen materials. This could mean that the comet has a more reflective surface than typical comets, whose nuclei are mainly composed of darker, harder-to-detect materials. The discovery of this extreme polarization has helped scientists better understand how light reflects off the surface of the comet and could provide clues about its origin and surface formation. These data are extremely valuable, as scientists can use this information to model the surfaces of comets and other interstellar bodies, which could help improve our understanding of the formation of objects in interstellar space. Comet 3I. Atlas is exhibiting a unique feature. Its activity was detected long before it was officially discovered in May 2025. NASA's TESS satellite had already captured signs of the comet's activity more than 2 months before its detection. This shows that, even though the comet was identified only in July 2025, it had already been active at much greater distances than typical comets, which raises questions about its nature and composition. Specifically, Comet 3I Atlas's activity was detected about 6 astronomical units from the Sun, a distance far beyond Jupiter's orbit. Comets in the solar system typically begin to heat up and release gases only when they approach the Sun much closer, like at 2 or 3 astronomical units. These observations suggest that Comet 3I Atlas may have different physical properties compared to other comets, which may mean that it underwent a series of changes before entering the solar system. This also suggests that interstellar comets may have unique characteristics that have not been observed in native solar system comets. These discoveries may, in the future, change the way we understand comet behavior and their interaction with the solar systems they pass through. With perihelion, the closest point to the Sun, approaching quickly, the scientific community is preparing to observe Comet 3I Atlas with even greater attention. On October 29, 2025, Comet 3I Atlas will pass 1.36 astronomical units from the Sun, which is between the orbits of Earth and Mars. At that point, the comet will be observed by telescopes around the world, and its bright coma and gas tail will likely expand, giving scientists and amateur observers a unique opportunity to study the interaction of the comet with solar radiation and the surrounding space environment. Currently, the comet is in the constellation Libra, and although it is not visible to the naked eye, it is accessible for observation with amateur telescopes. This allows astronomers worldwide to follow its trajectory and monitor its characteristics. For amateur astronomers who are interested in observing Comet 3I Atlas, it will become increasingly visible as it approaches the Sun and Earth, providing a rare opportunity to see an interstellar comet in detail. Once the comet reaches perihelion, it will begin to move away from the Sun, and its visibility will change again. Starting in November 2025, Comet 3I Atlas will be visible before sunrise, offering observers the opportunity to capture stunning images of the comet on its journey back to interstellar space. The journey of Comet 3I Atlas is a reminder of how vast and mysterious the universe we live in is. It offers a unique view of objects that come from beyond the boundaries of our solar system, bringing new data that could change the way we understand interstellar space. With each new discovery about Comet 3I Atlas, more questions arise, and more mysteries of the cosmos are revealed before our eyes. This interstellar comet, with its unique behavior and mysterious composition, challenges us to rethink everything we knew about these cosmic objects. Soon, new observations may help us better understand the origin of Comet 3I Atlas, the processes occurring inside it, and perhaps the role comets play in the formation of solar systems. Now that Comet 3I Atlas is in our solar system, it is giving us the chance to learn more about the universe in ways we never imagined. In the coming months, scientists, astronomers, and space enthusiasts will continue to closely follow its trajectory in search of more discoveries about this cosmic visitor and what it can teach us about the mysteries of the universe. With Comet 3I Atlas still in our cosmic neighborhood, we can't help but wonder what more will be revealed about this interstellar comet in the coming weeks and months. In any case, it is offering scientists and the public a rare and exciting opportunity to witness an unprecedented celestial phenomenon. If you enjoyed this video and were as fascinated as we were by the discoveries about Comet 3I Atlas, don't forget to leave your like down below. It helps us a lot to continue bringing quality content to you. And if you're not subscribed to the channel yet, subscribe now to not miss any updates on astronomy and other incredible phenomena of the universe. Also, activate the bell to receive notifications whenever a new video is released. Thanks for watching and see you in the next video.